Okay, so just to reiterate about the previous type of charging we talked about, that would be conduction. The idea with conduction is that two objects touch together, and because of the property that electrons don't want to be near other electrons, they repel away, they will spread out as much as is possible inside those two objects. And the way to do that, as long as the objects are identical size, is to evenly distribute between the two objects. That's what conduction is. I've got one more type of charging to talk about, and that would be charging by induction. So far we have charging by friction, which is just rubbing two objects together. Very simple. Whatever one object loses in electrons, the other object gains. We have charging by conduction, which is not rubbing by friction, but just touching two conductors together. Again, charges will transfer so that they are evenly distributed. Charging by induction is a little bit more complicated than these two. Okay, with induction, there is no contact between the objects that are being charged. Instead, the way induction always starts, it always starts with polarization. It starts with a charged object coming near another uncharged object, and that will cause polarization. At this point, a couple different things can happen. If there is more than one object, so I'll do both ways. A says if there's more than one object being polarized, the second object can be moved away. Now, both objects are charged. So let's say that we started with this. We started with two objects. They're neutral conductors. We know that they're neutral, again, because the charges are, the number of positive charges is equal to the number of negative charges. These are neutral conductors. So now what we're going to do is we're going to bring in a charged object. Okay, let's say that's positive. Okay, we bring in a charged object like that. And what's going to happen here with our objects, those positive charges, what are they going to do? They're going to attract the negative charges in this combined object. The positive charges in this object, or in these objects, I should say, are going to stay the same, or they're going to stay in place. What's going to happen is you're going to get polarization. You're going to get the positives staying in place, and the negatives in this original object are going to, well, they're going to want to go towards the positive, but the negatives in this one are going to want to go towards that positive as well. So they're all going to be kind of floating around over here, as close to those positives as they can get. Now, what you have happen is now you have polarized this. The left-hand object, even though they're touching, we're going to count them as different objects. The left-hand object is net negative, while the right hand is net positive. So right now, this entire object is still neutral. This side has a negative charge. This side has a positive charge. Now what we do is we separate the conductors. And it's very important you do it in this order. You separate the conductors and then remove the charged object. So now what you have, once you separate them, now you still have those positives locked in place, but these negatives that came over from the other object, they can't get back over to where they originated. So now look at the charge on this singular object. 1, 2, 3, 4 negatives, 1, 2 positives. That's a charge of negative 2e. And this is a charge of positive 2e. And this is a good time to remind you that, remember, not all of the electrons are going to go over to the side, but a good majority are. So it's not that there's no electrons left over here. I'm just choosing to draw only, let's say, 8 charges in this picture. So I'm going to just show the charges moving over there. In reality, there's billions and billions and billions and billions of, probably even more than that, of charges in here. I'm just kind of simplifying things down. Now, we have 2 completely new charged objects. And you actually already saw this, okay? I did the example earlier. I'll go back to it just to show it to you. I did the example earlier where we had 2 neutral objects initially. I don't know what the heck that was. All right, let's make these neutral. No, see, this is why I get frustrated. This thing doesn't want to do what I want it to. Okay, let's put the balloon over there. 0? No. Now it's just being ridiculous. Come on. Let's go. All right, that's it. I'm just going out and going back into this. This is being ridiculous. Okay. So, we have two objects, originally neutral. I'm going to have them touch. Ridiculous. There we go. Okay, I'm going to have them touch. Now, I'm going to bring in a balloon. I polarize the objects. I push most of those negatives over to that side. Now I separate the object. I remove the object that was doing the polarizing. Voila, I started with two neutral objects. I now have two charged objects. That is one method of charging by induction. Let me show you the other method, okay? And we know both these are charged because now one of them has more electrons than protons, so it has a charge of -8. The other one has more protons than electrons, has a charge of +8. Okay, let's go to the other method. This happens if there's only one object, and this actually won't work on my simulation, but I can show you the principle. If there's only one object, it can be what is called grounded by coming into contact with an object that allows electrons to flow from the earth, or we call it the ground, into the object. Or, I mean, you could also have it flowing out of the object. I'll explain how that works in a little bit. So let's say you have another neutral conductor. We know it's neutral. It has even amounts of positive and negative charges, in this case 4 and 4. Once again, we're going to bring in a charged object. Oh, I didn't write that over here, I guess. So it starts the same way, except this time we only have one object. So I'm going to do the same thing. I'm going to bring in a charged object, positively charged. We're going to get some polarization here. Okay? The positives don't move, but the negatives are going to flock to that side. They want to be near the positives. Okay? Now, what you can do is you do something called grounding. You figure out a way to link the conductor to the ground. By the ground, I just mean the Earth in general. The Earth is a huge repository of charge. The Earth is essentially neutral, but it's so big that even if you take a couple electrons from the Earth, it's still basically going to be neutral. No one's going to notice. So we still have this charged object here. And the symbol for this, for grounding, okay, still got my charges here. I've still got these charges here, but there's a symbol for grounding, and it looks like this. You attach like a little wire to it, and then you make a little arrow out of these little lines here. See how it looks kind of like an arrow if I were to fill this in? This is the symbol for ground, okay? What is going to happen here is once you attach to the ground, electrons in the ground are going to sense that, hey, there's a positive object up here. And electrons want to get near positive objects. So you're going to have some electrons coming up the wire, okay? Electrons are attracted by what they see as the lack of other electrons. They see this whole picture up here, and there's like, okay, hey, there's 8 positive charges, and they obviously can't count, but they're like, there's more positive charges than negative charges in this region. We're going to go up and make it balance out. We're going to go up because there's an overall net positive charge. The electrons are attracted to that. So they're attracted to this seeming lack in this region, including this object and this object, of other electrons. Now, if we had the reverse, if we had a negative object doing the polarizing and the electrons were pushed over here, the opposite would happen. The electrons would get a connection to the ground. They'd say, hey, let's get away from this other negative object. They'd go into the ground. They'd leave this object. So it depends on what object is doing the polarizing. The final step is when you remove the grounding wire here, and the original charged object what you're going to be left with is this. In this case, we had electrons come up into the object. We still have those positives in place. Remember, protons can't move outside the nucleus, but we now have more negative charges because they flowed up because they want to be near that positive object. What happens is once those electrons are in there, you cut the grounding wire, okay? You remove, so the electrons can't get back into the ground. You remove the original charged object, and now you're left with an object that originally was neutral, now has a charge of negative 4e because I had 4 electrons coming up. I highly encourage you to look over these drawings and make sure that they are exact. I did not draw arbitrary numbers of charge when I drew these diagrams. I didn't just, if you go back and look, I had 4 positives and 4 negatives here. I had brought in another object that had some positives on it, but then I took it away. I ended up total with 4 positives, 4 negatives here. They just rearranged themselves. I will be a stickler when you make these drawings, okay? You should not be introducing charge or taking away charge without any reason. There should be a conservation of charge reflected in your drawings. In other words, if you start with, let's say, 4 positives and 4 negatives over here, granted, we did introduce 4 more negatives in this drawing because they came up from the ground, but I shouldn't end up with like 17 positives and 36 negatives over here. That's not what happened, okay? Your drawing, treat these little charges like every one is important. You shouldn't be just introducing or drawing however many charges you want. You should set that at the beginning and then introduce or take away as necessary, or move their positions as necessary. It will take a little bit of time to get used to that, but I will be a stickler and I will point it out when I see it, okay? Let's see here. Real quick, let me just show you the idea of grounding. I can't show you grounding by induction because I don't think it quite works with this, but here are my 2 charged objects from before. Where's my cursor? There it is. If I introduce this ground, okay, see, this is a link to the ground. Now, I have a positively charged metal bar right here. What happens if I move the ground onto my positive charge? Well, the ground is going to think, the electrons in the ground are going to think, hey, here's a region of positive space. Let's go up there because we're attracted to the electrons. The negative ones are attracted to all those positive charges. So watch what happens. Electrons flood into that object until it makes it neutral. Likewise, if I ground this object, these electrons don't want to be near each other. They're like, hey, let's get away from all these other electrons. So electrons will flow out of the object until it's neutral. Okay, once it's neutral, the objects are fine. But that's the idea of grounding. It's connecting objects to the ground or via a wire so that they can move out into or out of the objects. Okay, so final thoughts on charging. In class, what this would lead into is a lab, because all 3 of these types of charging can be demonstrated with the help of something called an electroscope. Obviously, that is a little bit impossible for us right now. I can try and show you some resources on electroscopes as we go. As a matter of fact, I should, because there are some questions on some future homeworks that deal with electroscopes, and you should be aware of them. But I will say this, so I will try and get you that resource. How objects become charged when we're going over it in class seems fairly straightforward, especially charging by friction, charging by conduction. Those are pretty simple. Charging by induction is a little bit trickier, but you should be able to follow the diagrams for what happens. And you can always go to this website, which I'll show you, and you can kind of play around and do that stuff for yourself. This is, I would say, probably the probably about the second hardest part of this unit is questions about charging objects. You need to make sure you are solid with this, okay? Knowing just about the nature of charge, people usually understand that not right away, but it takes a little bit. How to charge objects, the difference between all the charging methods and how they actually work. This is the hard part. The one thing you always want to remember, you always want to think about, is just constantly say to yourself, okay, in this case, what would the electrons want to do? Do they want to go near a certain direction? Do they want to go in a certain direction towards an object? Do they want to go away from that object? Are they going to move to the left or right? Are they going to move up or down? Are they going to go into the ground or come out of the ground? Okay, your question that answers, when you're drawing these pictures, every time you're unsure of something, your go-to thought is always, what would the electrons do? Okay, they're the ones that can move. What would the electrons do? I'm more than happy to help anyone out with this. This is, like I said, a kind of tough topic. Please send me your questions. I'm more than happy to answer them over a Mind, or even Google, whatever the video thing is on Google Zoom, or Google Hangout, is that it? I don't know what it's called. I'm more than happy to talk to anyone about this sort of stuff. Please make sure you're staying safe and healthy. Let me know if you have any questions, and I will see you again in 2 days. Bye.